low dependency database migrations and integration. That is a mouthful. It's a terrible, terrible name for a presentation, but here we go. Hi, everyone. My name is Dan Gillis. My pronouns are he, him, his. My website is dangillis.dev. I'm on Twitter at Gilchrestian. My GitHub is Gilchrest. Professionally, I've been in the technology industry for 22 years, 18 of which was with Starved for a Guest, a very large loyalty program before we were bought by Marriott. Currently consulting and have been around long enough to have worked with a number of different languages, including my first being Logo in 1983. Personally, I'm a dad, a husband, and an advocate for my two kids. I'm passionate about equitable, inclusive, accessible learning environments. I live here in the Boston area. I'm a sci-fi horror geek, and I'm a drummer. So this is a Go fun fact for me anyways. I've been working in and learning the Go language since 2016. And I've never spoken to anyone about Go, literally. Like I've been to a few Boston meetups and had some small talk there, but I've never worked in a company that uses Go, and I've never spoke. I don't have friends that use Go. I don't recommend it essentially, but I've basically been like reading and learning on my own, and so yeah, so that's my Go sort of journey so far. I decided to just put myself out here and do this for the first time. So hi, everybody. I have crippling imposter syndrome. I don't have a computer science degree, and I'm petrified to do this, but I am very happy to open up for Bill Kennedy, whose work I admire in the community. I'll try and keep this as brief as possible so we can get into the Go 1.18 party. So here we go. In no particular order, here are the tools I'm using as part of this presentation and demonstration from the Mage site. Mage is a make/rake-like build tool using Go. You write plain old Go functions, and Mage automatically uses them as makefile-like runnable targets. I think it's built by primarily by Nate Finch, who I believe is also a Mass resident. I'm using Postgres as the database. It's open source. It's awesome. You probably worked with or heard of it. In particular, I'm using the pSQL command line interface, or CLI, which comes bundled with most installations. For an all-purpose database client, I'm using JetBrains DataGrip product, which I find to be great. And for database integration code generation, I'm using SQL C, which we'll cover briefly later as well, but it's a fantastic tool, primarily maintained by Kyle Conroy. Finally, most of the live code I'll be doing is a part of my project Go API Basic, which is my own repo that attempts to provide a template for building relational database-backed REST HTTP APIs. It's a basic CRUD app, create, read, update, delete. But has a bunch of scaffolding to enable these operations. I started it just shy of 5 years ago, back in 2017, and the idea was to have as few dependencies as possible. So back when I started, and I think for better or for worse, the Go community ethos was sort of like, use the standard library. And I think we've gotten a little bit beyond that at this point. But when I started, that was very much it. And so I tried to build a project based on that. Anyways, so someday I might follow up with a presentation about that. But for now, we'll just talk about database migrations. So here's an image from the public domain of the Great Gopher Migration. Okay, I'm kidding. There's gophers don't really migrate, actually, I found out, but lemmings do, and they kind of look like gophers. So database migrations allow you to manage the creation and upkeep of database objects through code and version control, something which is traditionally difficult with databases. If you're coming from like another language like Ruby or PHP or Node or just about anything at this point, I think you may have used some form of database migration library or tool. Some migration tools will even allow you to migrate data as well, data migrations. Database migrations let you run a simple command to say database up, and the entire database structure for your project will be created. You can also run a command to bring the entire database down. So this, if you think about it, can be really helpful for the developer experience and helps to keep development teams in sync as well. A new developer can come in and have a local database up and running in minutes, and it will match exactly what other developers are working with. For me personally, I found this idea enormously helpful for iterating on database development. For instance, I've been building a fairly complex database structure with a lot of foreign keys. And, it's really nice to just drop the database, right into some DDL scripts and bring everything back up with the foreign keys back in place, rather than have to temporarily alter tables and disable constraints and then remember to put them back on and in which order. It's sort of a golden schema concept, and I think it's very effective. Currently, there are several Go solutions, several migration solutions in the Go community. The two most popular being Golang Migrate and Goose. There are others as well. Each language and library has its own way of doing things. For instance, this is the Golang Migrate library, which here you can see the CLI creates an up and down file for objects. So, you issue this command and it creates these files. And then you, as basically add your normal looking DDL. DDL is data definition language. This is like, so essentially you're adding your statements to create your tables. And so your up SQL and your down SQL. Your down is going to drop your tables. There's a note here about idempotency that we'll get to a little bit later. Here you can see actually running the migration up command using Golang Migrate, and it produces the table described before. And then subsequently, you can run the quote unquote reverse migration, and it will drop the table. And it says, go ahead and go look, and you'll see it. Some migration tools, this is an example from Ruby on Rails, have you build the database objects in pure code deliberately with no manipulation of SQL directly. You can see here they're building a products table, but it doesn't really, resemble DDL or SQL or anything like that. Each database migration tool, again, has its own way of doing things in this space, of course. And I think Golang Migrate and Goose are actually really fantastic tools. I definitely recommend checking them out if you haven't. Actually, I've used Golang Migrate, and it inspired part of what I'm doing here. For me personally, I love DDL and SQL. I'm a big database developer formerly, so I like to stick close to the database and the tools they're in. And in general, I like to reduce my dependencies on third-party libraries. Again, that sort of harkening back to use the standard library, which I think is problematic in some ways. But anyway, so if you look at the Golang migrate file, go.mod file, you'll see it's huge. They have, I don't know, 60 something dependencies built into it, which is, makes sense. They're trying to build a product or a library that can serve many different databases and many different platforms, et cetera. The Ruby library, Ruby library where it's just pure code, that to me is just too far away from DDL and SQL. So in the past, I would just write huge DDL or SQL scripts and execute them in a database client, but it can be laborious to deal with and it is error prone. I started to use these migration libraries, but it just didn't feel quite right to me. Um, you know, I was looking for like another repeatable way. I ended up with an alternate solution that uses no migration tool at all, but accomplishes basically the same thing, which is where Mage, DataGrip, and Postgres pSQL CLI come into play. Essentially, what I've done is leverage existing tools that I use to mimic what these database migrations do. In 2021, DataGrip released what they call DDL data sources, which does a really nice job of exporting DDL for each object as a separate file. Other DB tools do a similar thing, but many are just like a giant DDL data dump. But DDL data sources does a really nice job of determining sort of dependency order and creating the files for you in order. So essentially builds your migration, your up migration. So the Postgres SQL CLI pSQL, which generally comes, allows you to execute multiple commands or files at once and is native to the database. And then Mage, it just makes it really easy to run shell-like commands with an API that's easier to deal with than OSExec. That's from their site, actually. So in my project, my Go API basic project, I use a directory structure that separates the up and down files. Like if you look at, Golang migrates library, they'll mix the files together. I just find this a little bit easier to deal with. For the up directory, again, I use DataGrip to generate these DDL files. To be clear, like you don't need to use DataGrip at all, period. You can hand roll, or you can use dbeaver or whatever client you want, and you can to generate these DDL files. I just, DataGrip's got a nice feature in it, basically, that spits this out for me. This is something you can build yourself. So for instance, but it's just straight DDL, right? And so all of the down files I do generate myself, actually. Now, one thing I want to just point out here is the if exists or if not exist. The idea, it's mentioned in the Golang migrate library, is that these statements make these scripts idempotent, meaning you can rerun these scripts over and over, and it should yield the same results. So if you've, and we can go over that a little bit more, I can show you an example of that, so that's the basic data structure I've set up. A migrations directory with up and down subdirectories where I store these files. In my project, I have two Mage targets. In Mage, you can do things like Mage build or Mage run or whatever. You can create targets however you want. So these, I have a DB up and a DB down target where I'm overriding the environment here. You can, you can set the environment however you like. In mine, I'm just choosing to simplify it and override my environment. You can use your existing environment, or there's various ways to set your environment, but this basically, each of these targets calls this pSQL args function that reads and sorts the DDL files from the proper directory and builds a sequence of command line arguments using the appropriate flags pSQL needs to execute files. And these flags here, this -w flag means it won't prompt for a password as we're executing as a script. The -d flag means means to connect using a database connection URI, which you can see here. I'm building that as well. You can see all this code there in that library, how I build the connection URI and all that stuff. It's pretty straightforward. But and then for each file, I'm just looping through and adding this -f. So essentially, I build up this big argument string, series of arguments for PL SQL, and then ship it back to Mage, where it attempts to run it using its really nice SH package. So I'm calling pSQL, passing in that list of arguments, and away it goes. So with that, I'll jump in and try and do a quick demo, which is always nerve-wracking, but let me try that. Okay. So real quick, I'll just show you, this is data grip. And this is my existing schema here. I'm going to, the DDL data sources, they're actually down here attached to my database. This is just my own structure. GAB stands for Go API Basic, and then there's a demo schema, and then there's the tables, and there's a user-defined function here. You can essentially SQL scripts dump to DDL source, which will then spit out the files into that directory structure we talked about. Now, you configure these DDL data sources. This might not show up. Let me share that. Hold on. Okay, you should see that now. Let's see. So you configure the DDL data sources here, and you can choose, file per object with order for migrations. That's what I use. So this is where it determines the dependency order. So if you've got a table with foreign keys to a parent table, but that parent table obviously needs to be created first. That's what these data sources do a nice job of figuring that out for you and spitting out your list of files that you need. And this is the path where you set it to. I won't go into all the configurations, but essentially there's the tables. Let's see here, where am I? So you should see here. So I'm in I'm in my root directory of my project. You can see that in my scripts folder, I have the DB migrations directories with my up and down. I'm going to if I type Mage, you'll see my targets. I think, there we go. So you can see I've got a build and a run and a test, but I've also got a DB up and a DB down. So I'm going to take my database down right now. I'm going to say DB down. Okay. Oops, I shouldn't. Well, okay. So if I go back over to here to data grip and I refresh, here, refresh. Come on, data grip is a little slow right now. You'll see all my tables are gone. Oh my God. When I did this Mage DB down, I didn't run that in verbose mode. I just ran it regular. And so you can see that it doesn't give you a ton of detail. It does, give you notices from pSQL that are somewhat helpful, but essentially, when you do a cascade on, when you drop a table and you say cascade dependencies, it's going to drop any foreign key dependencies associated to that table. And so it's just giving you notice here that it's dropping those. So if I say Mage-V, dB down again, this is that idempotency we were talking about. It's going to actually rerun that script, and this time it's going to actually give me a little bit more detail. And you can see that it's actually showing me each of the drop statements. It doesn't give you like a nice drop table was success. It's spitting out exactly what the pSQL command line interface returns, and that's just not helpful. It's helpful, but essentially you got to get comfortable with the fact that drop table means the drop table is successful. But it's saying here like because it doesn't exist, it's skipping it. It's idempotent. It didn't error here, it didn't blow up. It just continued on and it worked fine. So you can also see when I do verbose, you can see what's happening in the execution. So the pSQL command with those flags we talked about, and then here's the connection URI. So, I've got the password here, which is, obviously there's different ways. If you look at the Postgres documentation, you can store your password in another file so that it doesn't show up in your connection URI if you're concerned about this kind of thing, which you should be, but it's local development. I'm okay with it. And one thing I want to highlight here is the search path. I always set search path on my connections. A search path is essentially in Postgres, and I think MySQL has the same thing, and some other databases as well. It's like what schemas within the database that I have connected to can I look in, essentially, and in what order. That's essentially what a search path is. So you can limit the scope of exposure that your application has by setting a search path. So here I'm setting search path to demo. So I can only access things in the demo schema within my database by setting that search path. So this connection URI I built here, always sets that search path option. And then I'm just selecting some helpful information from the database, what database am I connected to, what user, what version, etc. So that's the down, and just real quick to show you, mage-b db up. Now I'm going to try and bring it back up. So, okay, same idea. You can see that it built the command with all the, it also appends, like we talked about, it appends all those files that it needs to process into one as part of the command. So it's processing, I don't know, 11, 12 files here. And it's just ripping through, and each of one of these is a successful, DDL statement, essentially.
Yeah, it just takes a really long time.
So that's really, in a nutshell, how I do migrations without really low tech, and no magic. I'm just trying to make use of the tools that already exist. So related, that's sort of, quickly I'm going to move on here because I know I'm kind of going a little bit longer than I wanted to. I just want to jump back in and, just talk about real quick. I also want to share my love for one really important piece of database integration, and that's the SQL C tool called Kyle Conroy built. It's awesome. You just write SQL, it generates code to interact with the database for you, and you don't need to use an ORM or anything like that. It saves a ton of time, boilerplate, and headspace as it makes some design decisions for you. And from what I can tell, it does a better job than at least what I can do. So let me share that real quick. Okay, so SQL C is related, as as DDL data sources. I also use that. You can, instead of spitting out all your files as like a file per database object in order, you can also spit them out just as a list of objects, but not in dependency order. So you can see in my DB objects directory, I've got all my tables, and I also have my function in here. In my opinion, this is really how you want to keep your database tracked in Git. You want to have a static list of database objects so you can see them change over time. Regardless of whether or not you use SQL C, I just think this is, I highly recommend doing this. In order for SQL C to understand your database, it relies on these DDL files. It doesn't connect to, it doesn't connect to your database or anything like that. It just uses DDL to understand your schema. So these files here that are in the separate directory, serve as the basis for everything you generate with the SQL C tool. SQL C, you set it up. You can use YAML or JSON, so that should say /JSON. But and there's a lot of configurations that you can do, but these are some of the basic ones. I'm telling it create the files in a package called Movie Store. My CRUD app basically is like a CRUD app for movies. So you create, read, update, and delete a movie. Where to put the files that it generates. I'll show you this in a minute, but you literally just write SQL statements and it'll generate all the code for you. So you're telling it where are those SQL statements, and it's in the same directory, in my case, in a file called query.sql. And then for the tables the queries in that query.sql file that it references, where can SQL C find that schema? You have to tell that. And so you don't have to be as prescriptive as I'm being here. You can say it's in this directory, and you can use just one big DDL blob or whatever. And it works. SQL C uses, and this engine here, SQL C integrates with MySQL and Postgres, and I think they're now doing SQLite. It's a super active tool. Anyways, so what the SQL package is the specific SQL driver that it's using. So in my case, I'm using Jack Christensen's PGX library, which is fantastic. It took over for libpq. Libpq has kind of been shut down, and they're pointing everybody to this library. It's very different, but it's really good. Okay, almost done. Sorry. The second piece is the actual query. So you can see here, it's just basic SQL. You just need to add some annotations above each statement, and SQL C does the rest. So here's the annotations. I won't sort of drill into what each one of these ones does, but here, this is my create, which is an insert statement, and then it's going to basically, when it generates code, I want it to be the create movie function, and I want it to return a PGX, basically exact result of SQL. And then these are my reads, select star for movie. I mean, that's it. That's the only SQL you have to put in. This is the function, what the function name I want it to be. Here's my update statement. It's real basic. The SQL, you can write complex SQL and it works too. It doesn't have to be as simple as this. It doesn't have to just be you can join multiple tables. You can make it as complex as you want, and it handles it for the most part. So let me do my second and last demo here real quick of SQL C. Let me share here. All right. All right, let me try this again. Okay, real quick, again, those you don't have to use the DDL data sources, but if you do, you would just configure it to, instead of spitting out in order, you'd spit it out as just objects. So like, for instance, I would go in here, I'd say SQL scripts, dump to DDL data source, and then I would have configured it to be objects. And I would have basically chose the configuration. Oh, I'm not showing this right now. Sure. I would have chosen the configuration that says file per object by schema. So it spits out just the objects, but not in order with the schema. Okay, so those are, instead of those get put into this objects directory. Again, you don't need to use DataGrip. You can use any database client, and you can hand roll these yourself. This movie.sql file is just a create. It's just a DDL statement. Okay, and so if you'll notice here, I have my data store directory. People do this different ways. I have like a directory for each sort of domain area. So in my movie store subdirectory, this is where I have a SQL C directory, and you'll see that SQL C.yaml file and the query.sql. Now I'm going to delete these just to sort of run this demo real quick. Here's my queries again. Okay, where are we here? So I'm in that data store, movie store, SQL C directory. This SQL C directory I have here you can be anywhere. This is where I choose to organize it. And you, in that YAML file, you tell it where to spit out the file. So now I'm going to use the SQL C tool to say SQL C generate. Okay, and that's it. It's done. This takes a second to refresh up here. Okay, it just created 3 files. The db.go file, and you can configure what the naming convention for these files is as well. So it's like highly configurable. This is the main interface and struct that gets initialized for all the queries and transactions. And you can see it's got a helper function here that takes this interface essentially. And then, it did star expansion for us, right? So it looked into that schema file, it picked out the database table and created a model for us. You can name it whatever you want, but it created a struct for us. The whole thing with SQL C is type safe code. So it created it looked at how it was configured. It knows which columns are nullable or not, and makes the types accordingly. And so, and then in addition, sorry, a lot of content here. In addition, it actually will spit out all of your database integration code. So, here's all of these methods hang off of that struct we saw in the db.go file. And you've got, for instance, this create movie method. It takes in the create, you basically load up this create movie parm struct, and it will run, it will pass it, it'll run this db exec function and run it for you. Now, one thing one thing I want to note is this interface. You can satisfy this interface with many types. Okay, so a DB SQL data, a SQL DB will satisfy it. A SQL transaction will satisfy it. And like in the PGX library, a PGX pool will satisfy it. So this interface that they take to run your queries is very flexible, so that you can easily integrate with it. And so like just a quick example here, like in my service layer, you can see how easy it is to use this stuff. You know, like I have a create method in my create movie service, and I'll basically load up this parameter, and then I begin a database transaction. I'm using chaining here. I pass the transaction in and then call the create movie method, and then commit my transaction. And then, you know, the reads are similarly simple. So I'm passing in a pool, PGX pool into here, and then I'm running this find movie by external ID, and it's going to return you know, what that movie struct that we saw in the db.go file. So I just wanted to highlight that. That's pretty much it, I think. So let me just go back to here for a second. Share. Where is it? Okay. So I guess in conclusion, you can run all your database automations and integration without dependencies. Today, we were able to run database migrations directly from the command line without a third-party library, except Mage, which has only standard library dependencies, and generate code using SQL C that allows us to read and write from the DB without any dependencies at all. SQL C is a command line tool that will not be included in your go.mod file. It generates and just plugs the code in for you. And that's it. That's kind of all I've got for today. I went a little bit longer than I wanted, so I appreciate everybody's time. Thank you for listening. Appreciate it.